go ahead and share the screen again. All right. There. Move this over here. Okay. All right. So the first problem that we're going to be looking at is a factoring problem. And so the first problem here is that we need to factor the following polynomial. And we're given 15x squared plus 20x minus 12x minus. So I'll give you a moment to write that down. Okay. So can anybody tell me what the first step of factoring a problem like this might be?
Combining that x's.
When you say combine, do you mean taking the 20x and then subtracting the 12x to get 8x?
Yes.
Okay, so that would actually be the opposite of what we want to do. So when we're factoring, there are a couple of key features to the problem that you want to pay attention to, right? So if you look at this problem, we have, and sometimes I like to go ahead and number that I have one term, two terms, three terms, four terms here. And if you have four terms in a polynomial that you're trying to factor, that should indicate to you that we are going to factor by grouping. So we don't want to combine like terms here because then we'll have a three-term problem and basically we'd be walking backwards. What we want to do is take a look at the first two terms by themselves and then if we can, identify a greatest common factor to factor out of these first two terms. So a lot of times what I'll tell my students is you might want to draw like a dashed line here or put your hand to cover the second two terms. We just want to focus on the first two terms. Okay. So for the first two terms, is there a common factor? What is the greatest common factor that these two terms have in common?
5x.
5x, exactly. So what we're going to want to do is write that greatest common factor, 5x, outside of some parentheses, like so. So we'll write 5x here, and then I'll open up some parentheses, and I know that I need two terms in this parentheses so that when I multiply this out with the 5x, I get my original two terms back. Okay, so you could think about it like 5x times what will give me 15x squared. Well, I know I have an x here. I need one more x to get the x to the second power. So there has to be an x here. And then 5 times what gives you 15?
3.
3. So that's how I know that 5x times 3x will give me this original term back. So that's why I know that the 3x needs to be there. Then 5x times what will give me 20x? Well, I already have one x here, so I don't have to put another x. Okay. All I have to worry about is what is 5 times something that will give me a 20?
4.
Yeah. So we'll put plus 4 here. So 5x times 4 definitely gives you 20x. Okay. Then we'll ignore the last or the first two terms and focus on the last two terms once we have this set up. Okay. So this negative 12x and this negative 16, what is their greatest common factor?
-4.
Yeah, -4. So we'll factor out a -4, open up some parentheses. And again, since I have two terms here, I need to have two terms in the parentheses. So -4 times what will give me -12x?
A +3x.
Positive 3x, correct. Right. And so if you're a little bit rusty on your negatives and positives, just know that this negative times a positive gives you back the negative. So if you put a negative here, that would be incorrect because a negative times a negative would give you a positive, and that's not the term that we have right here. Okay. So it has to multiply to give you back the original term. Now -4 times, we need a +4 in order to get the negative 16. Does that make sense, or does anybody have any questions? Okay.
No.
So once once we believe that we've factored those correctly, we factored out the greatest common factor. Now we should be able to identify that, yeah, it looks like the stuff that we have in parentheses is the exact same. Now, if you get to this point and the stuff that you have in parentheses here differs from what you have over here, then you've made a mistake. They have to be exactly the same, and this sign in the middle has to be exactly the same as well. If this was positive, but this one was negative, then we would have made a mistake and would have to go back and fix that mistake. Okay. But since the parenthetical information, the stuff here is exactly the same, this now becomes the greatest common factor, which we can pull out to the front of the expression. So we can have now 3x plus 4. And then whatever's left on the outside of the parentheses are 5x and our minus 4. That will be our remaining factor, 5x minus 4. So that will be the end of the problem. This is fully factored. So we can go ahead and box this up. And we don't have to go any further. Okay? Does anybody have any questions? Okay. Well, Ms. Cottier left me a note that says that for these problems in the test review, which are in the workbook that I'm assuming that you guys have access to, that we're only going to work this one problem right now, but 1 through 3 are the questions that are similar to this, right? We just worked question 1. And you will have 2 problems like this on the test. So 2 problems that are very similar where you will be factoring by grouping. So make sure that you polish that skill before you go into the test tomorrow. Okay. So now let's work problem number 3. And I'll do this one on a different sheet of paper just so that we don't get confused. And this one, again, we're fully factoring, and it's 9x squared minus 16. Okay. So does anybody have any ideas as to how we would start or begin to factor this problem? Or what are some things that are popping out at you? What are the things that are swirling around in your brain?
9 and 16.
What about 9 and 16?
They're divisible by 3 and 4.
Right. And I think that you're on the right track. We know that 9 is divisible by 3. We know that 16 is divisible by 4. But more than that, I'm sure that when you guys were going over factoring techniques, Ms. Cottier talked about a special factorization called the difference of squares. And that is if you have something squared minus something else that's squared, we can factorize that into a plus b times a minus b.
Do we have to find the square root of 9 and 16?
Yes, exactly. Right. So in this case, what we could do is just use this formula to go ahead and factorize. And it really doesn't require us to do a whole lot of thinking. But because we know that 9 and 16 are perfect squares, that means that we can take their square roots. Okay. So in other words, what I usually tell my students is that we could rewrite, if we wanted to, we could rewrite this as something squared minus something else squared. right? So if we took the 9x squared and we took the square root of that, well, then we would have 3x. Because if we were to square this, we would get 9x squared. The same thing with the 16. We know that 4 squared would give me the 16. So since I have now rewritten the problem in this form, basically the 3x is going to play the role of A, and the 4 is going to play the role of B. So now I can just go ahead and apply this formula and write whatever my A is plus B, that's going to be the first factor. And then whatever A is minus B, that's going to be the second factor, and I'll be done. Okay, so that means that we're just going to use our formula, which says A plus B, right, in the first set of parentheses. Well, that's 3x plus 4. Okay, and then the second set of parentheses says A minus B, so we're going to put a minus sign here, and A is 3x, and B is 4. So we have used our formula, we've applied it correctly, and that's all we have to do. This is going to be the correct factorization of the original expression. Does anybody have any questions about that one? Any questions, comments, or concerns? Right?
No.
Okay. All right. Well, then we're moving right along. Okay. It looks like the next problem that she wants us to work is we're moving on to solving equations. Okay, so notice that when we factor, that we don't have any equal signs in these problems, right? So if I look at the problem, the first problem we worked, we just have 15x squared plus 20x minus 12x minus 16. There's no equal sign in this expression. And so that's how I know that it's just an expression, it's not an equation. Expressions don't have equal signs. We can rearrange them, we can rewrite them, but we cannot solve them. You can only solve equations. Likewise, with this problem, we just had an expression. There's no equal sign, so there's nothing to solve. We're just rewriting the original expression into its fully factored form. So factoring expressions does not require you to solve anything. That is, we're not going to set anything equal to 0. We're not going to solve for x. We're not going to have something like x equals some number, right? But in this next set of problems, the instructions explicitly ask us to solve the following by factoring. Okay, so that key word here, solve, is what tells us that these problems are going to be different. And for these problems that we have to solve, these equations that we have to solve, we go one step further after we're done factoring. Okay, so let's go ahead and take a look at this first problem. We're going to skip to number 5 and look at 3x squared minus 2x minus 5 equals 0. Okay, so again, remember that I said with these equations, you have an equal sign. A lot of times they're set equal to 0 or something else, but the equal sign is what distinguishes how these problems are different from the last two that we worked. Okay. So we're going to start off the same way by sort of ignoring the 0 and the equal sign at first. And we just want to factorize this trinomial expression, right? We have an expression with 3 terms. So that's one thing that you might want to identify, right? That we have 3 terms. We have 1 term here, 2 terms here, 3 terms here. And in my head, or at least what I try to get my students to realize, is that when you have 3 terms, that you are factoring a trinomial And the way we factor a trinomial is, well, the way that I discussed on Thursday was using the AC method. But if you're more comfortable with the FOIL method, you could use the FOIL method as well. But essentially what we're trying to do is we're trying to take our 3-term problem and turn it into a 4-term problem just so that we can fall back on factoring by grouping. So what do I mean by that? I'm going to go ahead and demonstrate the AC method, which requires us to say that, okay, our coefficient for the first term is 3, that's A, B is -2, and C is equal to -5. Now, I tell my students all the time that we call it the AC method for 2 reasons. One, because this method is really cool, which is my go-to joke for this particular kind of problem. And the second reason that we call it the AC method is because we're going to multiply A times C. Okay, that's probably the actual reason. So A times C is going to be -15, right? We can do 3 times -5 is -15 over here. You might want to put your scratch work over to the side. Then we're going to look at the factors of -15, like 1 and 15, 3 and 5, 4 doesn't work, and then we're back at 5. So these are all of the factors of 15, and we're trying to combine them in some way so that we can get this middle term. That is, we want the 2 factors to multiply to give us -15, and we want those 2 factors to add to give us the -2, or the B. Okay. Does anybody have any problems with that? So if we're looking at these factors of 15, what are the 2 numbers here that are going to give us a 2 when we combine them?
-3 times 5.
Yeah. Well, actually, we're trying to get a -2, right? So
-3, -5.
it needs to be a +3
Oh,
and
okay.
-5. Okay. So the reason why one of them needs to be negative and only one of them is because if they're both negative, they would multiply to make a +15, right? So that's why we know that one of them needs to be negative. And the reason why you can decide that the -5 has to be the negative is because when we add them together, we can get that -2. Both of these conditions need to be met. If only one of them is met or neither of them are met, then we cannot use those factors, okay? But here we have, if we have 3 times -5, that gives us our -15, so that checks out. And 3 plus -5, which is the same thing as 3 minus 5, will give you -2. So that works. Okay, does that make sense? Okay. Well, what I like to do is go back to the original problem now, and we're going to take the middle term and break it up into 2 terms. And using these factors that we got over here, we can go ahead and rewrite this as +3x minus 5x. Okay, so these 2 factors over here are basically what we're using to break up this middle term into 2 terms. And you can verify for yourself that if you were to combine these terms, they would in fact give you -2x. Okay, so we haven't changed the problem, we've just changed what it looks like. We can go ahead and bring our 3x squared and the -5 down. So 3x squared comes down and the -5 comes down as well. Again, I'm sort of ignoring the equals 0 here, but we don't want to forget about that. We just want to fully factor this expression first. So now that we have 4 terms, we can go ahead and draw a little dashed line and factor by grouping like we did on the first problem. Okay. The first 2 terms have what in common?
3x.
Yeah, 3x. So what should go in the parentheses?
X plus 1.
X plus 1. Good. And then what is the greatest common factor for these two terms?
-5,
Yeah. And then what should go in the parentheses?
x plus 1.
Yeah, should be the exact same. Okay, and then if you were to distribute just to double check, it checks out, right? We get our original terms back. And since the stuff in parentheses matches exactly, the exact same terms, exact same sign, we can go ahead and factor that out to the front, x plus 1. And then the stuff that's left over, the 3x minus 5, that's going to be your other factor, okay? But are we done here?
No.
No. So when the problem says solve the following by factoring, you'll factor first, but then you have to keep going, okay? If the problem simply said factor, then we would be done. But we need to solve this. And this is set equal to 0. I'm sure that Ms. Cottier has covered with you guys something called the zero factor property. And the zero factor
Yes.
property is really simple. It just says that if you have A times B, you have two things that you're multiplying together. They could be numbers, they could be polynomials. If you get 0, what that means is that either A is equal to 0 or B is equal to 0. So what we'll just do is set each of these factors. X plus 1 is equal to 0, and 3x minus 5 is equal to 0. And then all we have to do is solve these equations, and then we'll have our values for x. We'll have our solution set. Okay. So to solve this one, we would just have to subtract the 1 over to the other side. So we get
-1.
x is equal to -1. There's one solution. And then for this one, it requires 2 steps, but they're very similar, very simple. We're just going to add the 5 over to the other side. We'll get 3x is equal to 5, and then we'll divide by 3 so that we get x is equal to 5/3. So those are our 2 solutions. Does anybody have any questions about that one?
No.
Okay. Let's go ahead and look at number 6. Number 6 is written in the form 2x squared is equal to -18x minus 36. Okay. So can anybody tell me what do you think the first step would be in this problem?
To move over the negative ax and -36 to the other side, and then go to 0.
Exactly. So when you're solving a quadratic equation, you want to have this in standard form. Standard form is just the form ax squared plus bx plus c is equal to 0. So you want to have this thing set equal to 0. So to do that, in my head, I would just say move these guys over to the other side and then change their signs to the opposite. That's the same thing as saying, okay, if we wanted to move things around, we would have to add 18x on both sides and add 36 to both sides, right? These would cancel out. So we would be left with 0 on the right-hand side. And we would be left with, if we put this in the correct order, 2x squared plus 18x plus 36 equals 0. Okay. So now that we have this in standard form, we can go ahead and solve this by factoring. So last time we went straight into the AC method, or into the FOIL method if you prefer that. But what I would say is you want to hold your horses on this one. Because if I look at all 3 of the terms, they all have a common factor. And it's going to make my life a lot easier if I just factor that out first. Okay. Now, the common factor that I see that they have is 2. So I'm going to factor out a 2, and that will leave me with x squared plus 9x plus 18 equals 0. Is everybody okay with that, or is there any questions or concerns? Cool beans. All right, so now that we've factored that out, we're still looking primarily at this trinomial. We want to go ahead and factor this further using our AC method. And it's going to be a lot easier to do because now we're not going to have to multiply 2 times 36. We're just going to have to multiply 1 times 18 and look at the factors of that. Well, 1 times 18 is just 18. So let me go ahead and do my scratch work over here. We're looking at the factors of 18. And that is 1 and 18, 2 and 9, 3 and 6. And we want to choose the factor pair that will give us back this 9. So it looks like 3 and 6, if they're both positive, they will multiply to give us our 18, but they'll also add to give us the 9. So from there, again, we're just primarily focused on this trinomial. We'll break open the middle term into 3x plus 6x, and we can bring our plus x squared and our plus 18 down. Okay. Now notice that I am not forgetting about the 2 that I factored out, and I'm certainly not forgetting about the 0. I'm just sort of ignoring them right now. They're not the main dish. We want to be factoring this trinomial. So we'll go ahead and do that by continuing our factorization method. We'll factor by grouping since we have 4 terms. These 2 terms have what in common?
X.
Yeah, just an x. So if we factor out an x, that should leave us with an x plus 3 here. Is everybody okay with that? Sounds good. And then over here, what do these 2 terms have in common?
6.
6, right? 6 would be the greatest common factor. You might look at them and say to yourself that they have a 3 in common or that they have a 2 in common. But remember, we want to take the greatest common factor, that is the biggest number that goes into both of them. So we'll go ahead and put our positive 6 out here. And if we pull out that 6, we should have x plus 3 left over. You can verify again by multiplying that back in, and you should get the original 2 terms back. Okay. Now that the stuff in parentheses is exactly the same, that means that we have not made a mistake and we can continue moving forward. We'll go ahead and pull that out as our greatest common factor. So x plus 3 comes to the front, and x plus 6 goes to the back. And honestly, it doesn't matter what order you put that in. And then we'll go ahead and remember that we're not done here. We're trying to solve this equation. So we have to continue. We have to remember that we had a 2 here. So I need to put the 2 in my expression. And I also need to bring the equal 0 back down, right? So that we can finish solving this problem. Now we can go ahead and use the 0 factor property, which tells us that we can set each of these factors equal to 0. But here, if I set 2 equal to 0, that doesn't make any sense. If this is a statement that the number 2 is equal to 0, it just is nonsense. So I can ignore that because 2 is never going to be equal to 0. Okay. But if I set x plus 3 equal to 0 and x plus 6 equal to 0, well, those are equations that I can now solve. And when I solve them, I will get x is equal to -3 and x is equal to -6. So those have to be in my solution set. Does anybody have any questions? Okay. Well, in the review, these were problems number 4 through 6, and we just worked number 5 and 6. But those are problems where you're solving a quadratic equation using factoring as the method of solving. And there will be 2 problems on the test that will look like that. The numbers might be different, but it's going to be the same process. Okay. So just keep that in mind. And if we have no questions about those problems, we'll move on to the next set. Okay. So the next set of problems asks us to solve the following by the square root property. Okay, and for these, this is problem number 7 through 9, and there are about 2 problems like this on the test. But we're going to start with number 8. Number 8 says that we have this equation. We have x plus 9, that whole quantity is being squared, and that is equal to -6. So I'll give you a little bit of time to write that down. Once you have that written, can anybody tell me what is the first step for solving a problem that looks like this?
Square root both sides.
Yeah, absolutely. So this square root property, if you recall from your lectures, is the property that says if you have some expression like x squared is equal to some constant, then what we can do is take the square root of both sides, because the square root will cancel out the square or the exponent of 2 because they're opposite operations. So these would cancel out, and that would leave us with x over here. But the thing we have to watch out for is that if this is a term that we can take the square root, we'll have to simplify that. And also, you will get 2 solutions, plus or minus the square root of whatever we have over here on the right-hand side. So if I was looking at a problem like this, I would probably go ahead and rewrite it. And then I would apply that square root property so that I can cancel out the square on the left-hand side. But that's going to create some problems of its own that we're going to have to deal with here in a second. The square root and the square cancel out, so we will just have x plus 9, and that's equal to, you can't forget, plus or minus the square root of -6. Well, we need to simplify that, right? So I'm fairly certain that we cannot simplify the square root of 6. But when you have the square root of a negative number, we should know at this point that that's going to be an imaginary number. So we would have I times the square root of 6. And then if we could break this down and rewrite that expression, we would. But if you notice, 6 only has 2 factors. It only has 2 and 3. So there's no way to simplify this expression further. So we can go ahead and proceed with the rest of the problem.
So once we use the I in front, we have to worry about the negative inside the square root.
Right. And that's because, remember, I is equal to the square root of -1. So what we've done essentially is we said, if we had -6 inside the square root, I could rewrite that as the square root of -1 times the square root of 6. So this is the part here, the square root of -1, that becomes the I. And you have to leave the square root of 6 alone.
Okay.
Okay, so that's why we rewrote it like this. But now the name of the game is just that we need to get x by itself. And so really we just need to move this positive 9 over to the other side. And I like to think about it as just moving it right here in front of the plus or minus. And in order to move that positive 9 over to the other side, you have to subtract it. So the sign is going to change. So we have x is equal to negative 9 plus or minus I square root of 6. And so that will be your solution. And technically this is two solutions. Sometimes the solution set is written in braces like so. And so your two solutions would be negative 9 plus I root 6 and negative 9 minus I root 6. But you can leave it like this because this would be a condensed form. It's less writing that you have to do. Okay. Does anybody have any questions?
No.
Cool. Okay, let's take a look at another one that's like that. Let's look at number 9. Let's go ahead and solve 9x plus 7 squared is equal to 11. And again, we have something squared is equal to a number. So right off the bat, that should be signaling to you that we need to use the square root property, take the square root of both sides. Okay. So let me go ahead and rewrite this problem. And I'll go ahead and take the square root of both sides. Remember that the square root will cancel out the square on the left-hand side of the equation. So we should just have our 9x plus 7 by itself now. And that's equal to plus or minus the square root of 11. The square root of 11 can't be simplified, so we're going to have to leave it like that. And be very careful there. We do not need the I because we do not have the square root of a negative number. The square root of positive 11 is fine, and you can just leave it alone. Okay. So now we just need to worry about getting x by itself, and we're going to do that using all of the rules that we've learned before. We're going to use either addition or subtraction to move something over, and then at the very end we'll use division or multiplication to cancel something out, right? So what I would say is we need to move this 7 over to the other side, and to do that we would have to subtract the 7. Okay, so we would have 9x is equal to negative 7 plus or minus the square root of 11. And then to get the x by itself now, the last step would simply be to divide both sides of the equation by 9. So we can cancel out the 9's here. We have x is equal to negative 7 plus or minus the square root of 11. All of that is over 9. And this would be your final answer. I feel like that went a little bit fast, but do you guys have any questions? Cool beans. Just moving right along. Okay. So far what we've seen is that we can solve quadratic equations using two primary methods, right? We can use factorization in some cases, but then in other cases, using the square root property is going to be the fastest way to solve those quadratic equations. In these next set of problems, we're still going to be solving quadratic equations, but we're going to use our final method, which is using the quadratic formula. So we need to solve the following using the quadratic formula. Does anybody remember what the quadratic formula is? And this is questions number 10 through 12.
Negative b plus or minus the square root of b squared minus 4 times AC over 2A.
Yeah, that's it. Okay, so I always tell myself the story of the negative boy whenever I write down the quadratic formula. And that is x is equal to, or whatever the variable is. The negative boy was unsure of whether to go to the radical party because the boy was a square, so he missed out on 4 awesome chicks, and the party was all over at 2 a.m. in the morning. Okay. So it's negative b, the negative boy, plus or minus, was uncertain of whether to go to the radical party, so that's the square root, because the boy was a square, so he missed out on 4 awesome chicks, and the party was all over at 2 a.m. Just a little helpful mnemonic device in case you guys want to tell yourself the story of the negative boy. I'm sure that you guys are able to use a sheet of notes or something like that, so you don't have to memorize that. But if you felt like challenging yourself in memorizing the formula, that's one good way to do it. Let's take a look at number 11. We need to solve this quadratic equation. 4x squared plus 6x is equal to -1. Okay. So the first step is always going to be for either solving using the quadratic formula or for factorization, is that we have to get this in standard form. Again, standard form means that it's set equal to 0. So we need to get ax squared plus bx plus c is equal to 0. So right off the bat, that's going to tell me that we need to move this one over to the other side, add it over to the other side so it becomes positive. Okay, so we have 4x squared plus 6x plus 1 is now equal to 0. Is everybody okay with that? All right. Well, now that we have that, we can go ahead and label our coefficients in the quadratic or trinomial. We have a is equal to 4, b is equal to 6, c is equal to 1, and we're just going to simply plug these numbers into our formula. Okay, but be very careful. Every semester without fail, students will plug in the variable x. Like for instance, if b is 6, they'll take 6x and they'll put 6x into the formula. You just need to take the coefficients, not the variables, just the numbers. Okay. And what I would recommend doing if you were solving this by hand is plug everything in, and then there's a specific order in which you will simplify the expression so that you run the risk of making fewer mistakes, okay? So first, x is equal to, we're going to do negative b. So I'm going to open up parentheses wherever there's a number that I'm plugging in, plus or minus the square root, parentheses squared, minus 4 times something else, all over 2 times something. Okay, and then I'll go ahead and plug whatever those somethings are. Okay, so b is 6, so I'll put 6 here and 6 here. I wish I had 3 colors here, but I don't. A goes here and here, so that's 4 here and 4 there. And then C is just 1. Okay. And what I highly recommend doing is start by simplifying this if you can. So we'll just leave that as a -6, plus or minus. And then what I would do is you could throw the radical stuff into the calculator. But I would just do the stuff inside the square root. Do not include the square root because sometimes you'll have a negative inside the square root, and your calculator, if you have a TI-84 or something similar to this, usually can't handle imaginary numbers. Okay, so we'll have to handle that by hand, right, manually. And you could type in exactly the way we wrote this, parentheses 6 squared minus 4 times 1. and we should just get 20. Okay. So we'll have the square root of 20 here all over, and then 2 times 4 is 8. Okay. Now, some people might be tempted to just leave this as it is, but it turns out that we can simplify the radical further, because 20 can break down into, what could we break this down into? 4 times 5. And so we can take this, if we're taking the square root of 20, we could take the square root of 4, and that'll just become a 2, but we can't take the square root of 5. So we'll have to simplify the square root of 20 into 2 times the square root of 5. So I'm just going to go ahead and replace the square root of 20 with 2 root 5. -6 plus or minus 2 root 5 all over 8. Okay. Does anybody have any questions about that? Okay. Well, the last step is going to be to factor something out and then cancel that. If you look at the 6, the 2, and the 8, they have something in common. We can only factor something out of the numbers that are not trapped inside the radicals. So that's why I'm only focused on the 6, the 2, and the 8. Well, it turns out that we could divide each of those by 2. So we can think about reducing that fraction by 2 and just getting this as -3 plus or minus root 5 all over 4. And that will be our final answer. So you could think about this. Somebody told me that this is like a Dorito chip. I'm basically reducing by 2. Does anybody have any questions about that? I could go back and explain those step by step. I think right here and right here, I might have sort of breezed through the concepts. But does anybody want me to further elaborate how this or this worked? Okay. Cool. Well, if you ever, for whatever reason are too timid to speak up in class, that's perfectly fine. It happens to everybody. That's exactly why Math World exists. So I'm always going to be pushing students to go visit with our tutors in Math World if you need, help talking through some of those things to get the deeper explanation. But since we have no questions, let's go ahead and move on to the next problem. Next problem is number 12. And this one is set up as 2x squared is equal to -5x minus 7. Okay. So again, if I were to rewrite this in standard form so that I can start this problem, what would I need to do?
You have to plus the 5 and the 7.
Yeah, exactly. I have to add 5x and add 7 over to the other side, right? So if I did that, you could do that in your head if you feel comfortable doing it. Just move those guys over to the other side and change their signs. And now we have this set equal to 0. Okay. Now here, remember, we're using the quadratic formula to solve this expression or solve this equation. So you might feel tempted to factor if you're, sort of on autopilot. But just remember to read the instructions. We're trying to use the quadratic formula. So I'll go ahead and label this as A is equal to 2, B is equal to 5, C is equal to 7. And then I'll just drop everything into my formula. So I have -b plus or minus the square root of b squared minus 4 times a times c all over 2a. And then again, I like to backfill the parentheses once I've set up the formula. So we need a b here and here, that's 5. And then we have a here and here, so that's 2 and 2. And then c is 7, so we'll leave that as a 7. And then we'll just simplify this one step at a time. So this is -5, nothing strange there, plus or minus the square root of, and you could throw this all into the calculator, which I will do now, but just make sure that you throw it into the calculator exactly the way that we wrote it. So parentheses 5 squared minus 4 parentheses 2 parentheses 7. And we get -31. So just to show you guys, if I had put the square root first and I had put that expression 5 squared minus 4 times 2 times 7, the calculator would have given me an error and says non-real answer. That's because we would have had an imaginary answer. So that's why I just want to put the stuff inside the radical into the calculator and call this -31, because I know that if my calculator can't handle imaginary numbers, then I'm going to have to handle it manually. Okay. So that's all over 4. I really think that 31 is prime, so we can't simplify our radical expression. So what we can do is say that the square root of -31 is simply I times the square root of 31, since this is going to be an imaginary number. So we have -5 plus or minus I times the square root of 31 all over 4. And since these three terms don't have anything in common, I can't reduce our fraction. I can't reduce the solution. So we're just going to have to leave our solution as it is. This is as simplified as we can get it. And that will be your solution, or your solution set, right? Because this is really 2 solutions. Does anybody have any questions? Okay. Moving right along. So in section 1.6, you guys solved all kinds of equations, rational equations, radical equations, equations with rational exponents, and things that were in quadratic form. So now we're going to get a set of instructions that just say solve the following. And based on how the problem looks, solve the following. We'll have to determine for ourselves what is the method that we use to solve the equation. Okay. So in the review, questions 13 through 15, you have rational equations, and you'll have 2 problems like this on the test. So we'll start with question 14, which is 5x over x minus 5 minus 4 over x is equal to 20 over x squared minus 5x. Okay. So whenever you have these algebraic fractions with variables in the bottom of the fractions or in the denominators, these would be rational equations. And I would tell you guys that the first thing that you have to do when you're solving a rational equation is find the restricted values. That is, there are certain numbers or values of x that cannot be solutions for the equation. Okay. So if I'm just inspecting the denominators of these equations, I might say to myself, well, hey, this denominator here can be factored. So we could just factor it, and we'll see that we'll have x times x minus 5. Okay. And then we might ask ourselves, what is the value of x that might make our denominators equal to 0? We cannot have a denominator of 0 for fractions because fractions are division problems. And so if we have something over 0, that's like saying that we're trying to divide by 0, and we simply cannot do that. So what value of x will make this expression in the denominator 0? So these are our restricted values. Well, if we set x minus 5 equal to 0 and solve that, we would get x is equal to positive 5. Right? So that means that if I plug positive 5 in here, I would have 5 minus 5, which would be 0, and then I would be dividing by 0. So that cannot be one of my values, can't be one of my solutions. For this denominator, what is the value of x that would make this equal to 0, this denominator? Well, that means x cannot be 0 here, because if I plug in a 0 here, I would have 4 divided by 0. And then since this denominator, when we factorize it, it turns out that it's made up of each of these factors, well, I don't have to do any additional work. My two restricted values are that x cannot be 5 and x cannot be 0. Does that make sense? Okay. All right, well then the next thing I would do is we need to somehow multiply something into our equation so that we have an equation that no longer has fractions, because that's going to be one of the easiest ways to solve this equation. So I'm not exactly sure the method that Ms. Cottier has showed you guys to do this. The way I teach my students is that we need to take the least common denominator of each of these fractions, which is going to be x times x minus 5, and multiply that into the equation. So what do I mean by that? Let me go ahead and write this down. I'm going to multiply each of the terms by this LCD. So it's going to be a lot of writing. Bear with me. So we'll have this minus 4 over x. Going to leave myself some space. 20 over x. And I'm going to write this in factored form. So x times x minus 5. Okay. But I'm going to write this LCD next to each of my terms. So I have one term here, one term here, and one term here. So I'm going to write this LCD 3 times. So I'll put x times x minus 5 here, x times x minus 5 here, and x times x minus 5 here. A lot of writing. But when I multiply each of these terms by that LCD, part of the LCD will cancel out something in the denominator, right? Like x minus 5 and x minus 5 here will cancel out because essentially what we're doing is multiplying and dividing by the same number. So we can say x minus 5 and x minus 5 here cancels. So all we're left with is x times 5x. So x times 5x would be 5x squared. Similarly, on this next term, we have this denominator x and this thing that we've multiplied in, which is an x, and those will cancel. So all we'll have left over is negative 4 times x minus 5. So we can take that negative 4 and distribute it onto each of these terms, since that's what's left over, and we'll have negative 4x. Then negative 4 times negative 5 is positive 20. And then that will be equal to, well, this is actually really nice since the x here cancels out this x and the x minus 5 cancels out this x minus 5. All we have left over is our 20. So now this is starting to look like a quadratic equation. So that means I can go ahead and subtract the 20 over to the other side. Let's get this in standard form. Turns out that both of these cancel out. So we have 5x squared minus 4x is equal to 0. And then we have three methods of solving quadratic equations. So we can either factor this, we could use the square root property, or we could use the quadratic formula. Now, I only have two terms here, 5x squared and 4x, or negative 4x rather. And they have something in common that I can factor out. So usually if you only have these two terms left over, usually factorization will be the easiest way to solve this. So I'll just factor out the x. That'll leave me with 5x minus 4 is equal to 0. And I can use the zero factor property to say that either x is equal to 0 or 5x minus 4 is equal to 0. And since this solution is already solved, or this problem is already solved here, we just need to solve this equation over here. We can add the 4 over to the other side. So we get 5x is equal to 4, and then divide by the 5 so that we get x is equal to 4/5. So our solution set would contain x equals 0 and x equals 4/5. However, at the very beginning of this problem, we established that our restricted values, x cannot be equal to 5, nor can it be equal to 0. So what I have to say is, because we got this as a solution, x equals 0, we have to throw that away because it's restricted. So our only solution is x equals 4/5. All right, does anybody have any questions about that one?
You're gonna show us another one like the same?
Yeah, the next problem that we're going to work is going to be very similar.
Okay.
Okay. Let's take a look at another example of this kind of a problem. We have 6 over x plus 5 is equal to 1 minus 1 over x minus 5. Okay. So whenever you're looking at a problem like this, I would say the first step is to find the restricted values. So what values can we not use as solutions for x? That is, if we plugged in this number for x, it will make the denominators equal 0. So what would I have to plug in here so that x plus 5 was equal to 0?
Negative 5 and 5.
Yeah, exactly. So for this one, x cannot be equal to negative 5. And for this one, if I plug in positive 5, I wouldn't be able to use that either. Okay. And the second thing that we need to find is the least common denominator, which in a problem like this, we can just look at the denominators. We don't have to factorize anything in the denominators. We can just say that we have an x plus 5 that we sort of need to cancel out somehow, and we have a x minus 5 that we need to cancel out somehow. So if we multiply these in, we can go ahead and cancel these denominators. Okay. Again, I like to visually see that if we number these 1, 2, 3, we have 3 terms. We need to multiply each of those terms by our LCD. So I like to rewrite the problem, giving myself a little bit of breathing room to write these other terms in. Okay. And then next to each of the terms, I'll go ahead and write this LCD. And it's x plus 5 here and x minus 5 there, x plus 5, x minus 5, x plus 5, x minus 5. Sorry, I ran out of space. But the takeaway here is that we're going to cancel out something, right? Like for this first term, we have x plus 5 in the denominator, and that will cancel out with the x plus 5 that we just multiplied in. So what you'll have left over is 6 times x minus 5. For the second term, well, we multiplied these two in, but we're multiplying them by 1. So the 1 isn't going to change anything. All we'll have left is the x plus 5 and the x minus 5. Unfortunately, nothing here canceled out. Over here now, we know the denominator of x minus 5 will cancel out with this x minus 5 over here. So we'll still have minus 1 times x plus 5. Does anybody have any questions about that?
No.
Okay. So now it's just a matter of distributing, combining like terms, and just simplifying this. It's going to make a mess, but then we're going to try to clean it up after that. So what we can do is distribute 6 here and here, so that we have 6x minus 30 is equal to, if you distribute this out, we would get x times x is x squared. Then we would get a negative 5x, a positive 5x, and then a negative 25. So x squared minus 5x plus 5x minus 25. And then finally, we're going to take this negative 1 and distribute it here and here to get negative x and negative 5. Well, this is like monstrously ugly, so we'll go ahead and combine like terms so that we can clean it up a bit. So we'll just leave 6x minus 30 alone. It looks like we have a 5x here and a negative 5x and a plus 5x, so those will cancel to 0. What else do we have here? We have a negative 25 and a negative 5. So we should write this as x squared minus x, and then this should be negative 30. Well, now this is looking like a quadratic equation. So we need to get everything over to one side and have it set equal to 0. But I like to keep my squared term positive, and currently it is positive. So what I'll do is I will move the 30 over to the other side and the 6x over to the other side. So that means I'll have 0 is equal to x squared. And then if I subtract 6x there, I can cancel that out. But then here I would have to add 30 to cancel that out. So I would have negative 7x there. And then these would actually cancel out to 0. Does anybody have any questions about that? I know it looks a little bit strange because I have the 0 on the left-hand side. So if you want to switch it around and rearrange it so that you have x squared minus 7x is equal to 0, that's perfectly fine. It's the exact same thing. But what we're looking at now is a quadratic expression or a polynomial that's easily factorable. If you look at these two terms, they have something in common. So let's just go ahead and factor that common factor out. So we have x times x minus 7 equals 0. And now that it's factored, we can use the 0 factor property and say that one of our solutions is x is equal to 0, and the other solution, x minus 7 equals 0, is simply x is equal to 7 once we add the 7 over to the other side. So we have two potential solutions here. And as long as they're not restricted, then they're okay. Right? So our restricted values that we found at the very beginning of this problem are -5 and 5. Since neither of them are restricted, both of these solutions will work. Does anybody have any questions? Okay. All right, let's take a look at the next one. So for problems number 16 through 18, you're going to have two problems like these on the test. And we're going to start with problem 18. We're just going to do problem 18. So this one is the square root of 3x plus 10 is equal to 5 minus 2x. Okay. So to start a problem like this off, we would have to isolate the radical. That's always my first step here. So we have the radical expression already by itself. It's already isolated. So what we can do is go ahead and apply the corresponding power to cancel out that radical. Since we're dealing with the square root, then we're going to want to square both sides. So square both sides of the equation, just so we can cancel out the root. So I'll go ahead and write this as 3x plus 10 inside the radical is equal to 5 minus 2x. And I'm just going to apply the second power to both sides so that I can finally cancel out my root and just have my 3x plus 10 by itself, no longer in the radical. But unfortunately, we have to simplify this expression, which we've just made a little bit more complicated. Okay, so remember that we have to take this 5 minus 2x, and since we're squaring it, we're going to multiply it by itself. So this is sort of like my scratch work over here. We should be getting 5 times 5 is 25. 5 times 2, that's gonna be a negative 10x. We're gonna get another negative 10x here, and then we will get a positive 4x squared. I'm gonna go ahead and rearrange this to 4x squared goes first. These like terms become minus 20x, and then this is a plus 25. So this is the expression that I can go ahead and sub back into my equation. So 4x squared minus 20x plus 25. And then again, this is looking like a quadratic equation. So we need to move everything over to one side. What we can do is subtract 3x here and subtract 10 there, so that we get 0 is equal to 4x squared minus 23x. And then this would be it would be plus 15. So now, once we have this quadratic equation in standard form, we can go ahead and use either the quadratic formula or the factorization to simplify and solve this. So let's go ahead and try to factor this. I would multiply 4 times 15, and that should give me 60. So I'm looking at the factors of 60. That will somehow give me 23. So 1 and 60, 2 and 30, 3 and 20. And I can probably stop right there because -3 times -20 will give me my positive 60. And they'll also add to give me my -23. So I can take this middle term now and I can split that up into, I'm going to put the -20 first. So -20x minus 3x. And the only reason I'm doing that is because I know I'm going to have to factor here in a little bit. And I know that the 4x squared, that the 4 and 20 will have something in common, very straightforward. And that the 3 and the 15 will have something in common. Okay. You will get the same thing regardless of what order you put that in. But I just think that, let's make our lives a little bit easier. And noticing that the 4 and the 20 are closely related and that the 3 and the 15 are closely related, that's just a nicer order to put things in. So these two have a 4x in common. So that means I'll have an x here and I'll have a -5 there. These two have a -3 in common, so I'll have an x here and a -5 here. And the reason why it's -5 is because -3 times -5 will give me my positive 15 back. Okay. And lo and behold, the stuff in parentheses is exactly the same. Same terms, the same sign. So that means we're on the right track. X minus 5 times 4x minus 3 is the correct factorization. But remember, we're solving this equation. So since that's set equal to 0, we know if I set this equal to 0, x will be equal to positive 5 once I solve it and add the 5 over to the other side. And over here, I would have to add the 3 over to one side and then divide by 4. So I should have a positive 3/4 as my solution there. Okay. Now, again, with these radical equations, you have to check to make sure that these work. And if you check and plug these solutions back into the calculator, I'm going to leave that to you guys. But what I will tell you is that when you plug x equals 5 back into the original problem, you do not get the same on both sides of the expression. So this actually, once you check it, is not a valid solution. So just remember to check your solutions. Okay, does anybody have any questions about that one?
No.
Okay.
So how come I guess the -3 becomes like a +3, I guess?
Oh yeah, that's a good question. I just totally sort of breezed by that. But remember that you would get the 4x, right? At the end, we have our factorization x minus 5 and then 4x minus 3, right? And those are both set equal to 0. So x minus 5 equals 0. You would have to
Okay.
add 5 over to the other side, right?
Okay, yeah, I get. Okay, yeah, that makes
Yeah,
sense.
so in your head, you have to be thinking about, or actually, to avoid any mistakes, don't do it in your head, write it down. You'll see that you'll add the 3 over to the other side, making it positive now.
Yeah, I remember that now. Yeah, I just forgot about that for some reason.
Yeah. Yeah, so that's what I did in my head. I'm sorry for not explicitly writing that down. Let's take a look at the next problem. So for problems in the review number 19 through 20, it looks like you will have one problem like this on the test. So, oh, this one's a nice one. We have 16x to the fourth minus 41x to the second plus 25 is equal to 0. Okay. So I think that we covered this on Thursday when I was with you guys, and I showed you guys the U substitution method. But at the end of class, I also showed you that you don't need to do U substitution in order to solve a problem like this. This is called a quartic equation, or an equation in quadratic form. But in any case, whatever it's called, you have x to the fourth power here, and that's what distinguishes this problem from the other kinds of equations that we were looking at. And it also tells you that you will have 4 different solutions for this equation. Well, I think that it's way simpler to just not worry about U substitution and just immediately go into factoring. Okay. And this looks like it's going to be a little bit difficult in the sense that if I multiply 16 times 25, I'm going to get a really big number. But let's just go down that rabbit hole and see what happens, right? 16 times 25. We get 400. And so we have to look at all the factors of 400 to see how we're going to get a 41 out of that situation. So it might be, it might not be particularly useful to start at 1 and 400. But because I can't just look at this number and sort of guess what are the factors that are going to give me a 41, I'm just going to start at 1 and 400, right? So 2 and 200. I don't know if 300 works, or I'm sorry, I don't know if 3 works. It doesn't. 4 and 100. 400 divided by 5. Let's see. That'd be 5 and 80. 400. I don't know if 6 works. Doesn't. 400 divided by 7. I'm pretty sure that doesn't work. 400 divided by 8. So 8 and 50. I feel like we're getting closer. 3 didn't work, so 9 shouldn't work. So 400 divided by 10 should be 10 and 40. Now, if we add those together, we'll get 50, so we're sort of getting close. Let's see if 12 will work. 12 didn't work. 400. What could we do here?
25 times 16.
Yeah, we could do 16 and 25. I was getting there. Does 15 work though? 15 won't work. 16 and 25. Oh, and do those add to give us our 41? Yeah. Yeah, that's real nice. So that's it. It turns out that the things that we multiplied to get this number are the factors that we needed, and they do multiply to give us our 400, and they also add to give us our 41. So both of those conditions work here. We need to make them both negative though, because remember that we're trying to get our negative 41. But that's really nice actually, because now we can take this middle term and break it up. And I'll just call this negative 16x to the second power plus 25x to the second power. And I'll bring down the other terms. And then I can factor by grouping. And this is really nice because the 16s have something in common. It's a 16 and an x squared. That will leave me with an x squared in here because I need to get back to the x to the fourth. And this will be a minus 1, since that'll multiply by the 1 to give me the same term back. And the same thing is going on over here. We have a plus 25 in common, And that's all we have in common. We have x squared. Oh, this was a minus, wasn't it? My bad. So we had to take out a negative sign, and that'll flip the sign over here to -1. There we go. So both of these had a 25 in common, but since the first term was negative, we had to make that negative. So negative 25 times x squared is negative 25x squared. And negative 25 times -1 gives you the positive 25 back. Okay. If I hadn't done that, if I hadn't made that mistake, I wouldn't have gotten the same thing in the parentheses. But because we have the same stuff in parentheses here, that means we're on the right track. Our factors here are x squared minus 1 and 16x squared minus 25. And those are both equal to 0. Now we can set these equal to 0. So x squared minus 1 is equal to 0 and solve that one completely. If I move the 1 over to the other side, I get x squared is equal to 1. And then I can utilize the square root property, take the square root of both sides, and say that this is x is equal to plus or minus the square root of 1. Well, the square root of 1 is simply 1. So x is equal to plus or minus 1, right? Like if you put the square root of 1 in your calculator, it simplifies to just 1. Okay. So that's why I'm just getting rid of the square root here. And then we can go ahead and do the same thing over here. 16x squared minus 25 is equal to 0. We can go ahead and add the 25 over to the other side. So that makes it positive. We can divide the 16 over to the other side. So get 25 over 16. And then we can finally utilize our square root property, take the square root of both sides, and we'll get x is equal to plus or minus. And since this is the square root of 25 over the square root of 16, we can take the square root of these numbers and we will get 5 over 4. Okay, so that's plus or minus 5/4. So we have our 4 solutions, positive and -1 and positive and negative 5/4. Does anybody have any questions about that one?
You said when there's a square root, there's a plus or minus, like when we
Yeah, when you take the square root of both sides, when you take the square root of something squared, you have to put the plus or minus.
On this equation, do we have to check our answers?
No, you don't actually. Okay. Okay, so I think that yesterday, Miss Cottier was covering some material from section 2.3 with you guys. And that is you guys started learning about functions and domain and range. So let me change gears here a little bit. I'm going to stop sharing my screen. And let me share a different window with you guys. All right, there we go. All right. So let's go to where we are now. We are on question 25. Okay. So according to Ms. Cottier, for questions number 24 through 25, you're going to have two problems like this on the test. Okay. And she just wants us to go over number 25, which says to give the domain and range of the relation represented in the graph. Okay. So we're looking at the graph below. And can anybody just look at the graph and tell me what the domain of the graph is? What is the domain?
6 to infinity.
Yeah. Is anybody confused as to how he got 6 to infinity for the domain? So I'm going to write the domain here. D is, I'm going to write it as bracket 6, comma, infinity. Is anybody confused as to why that's the domain? Okay. Well, the reason why it's the domain is because when we're looking at the graph, to find the domain of a relation or a function, what you want to do is think about the x-axis as a measuring stick. You want to see what is the farthest left that the graph travels to. What is the leftmost boundary of the graph? What is the rightmost boundary of the graph? So when I say the graph, I am talking specifically about this curved line here. Okay, and I'm going to go ahead and highlight it sort of in purple. This is the graph of our relation. Sometimes students, they focus too much on the coordinates, the x and y axis. But when you're trying to find the domain, you can think about what is the leftmost boundary where the graph stops. And the leftmost boundary is right here at this sort of vertical line I can draw here. Well, we can do a straight line here. Right, that's the leftmost boundary. And it just so happens that that number that we pass through is 6. Okay. Now, if I wanted to get a rightmost boundary, that is the right side of this graph, well, it looks like the graph is going to continue going in this direction forever. So it's never going to stop. And so if we thought about the x-axis, if we were measuring using the x-axis would continue to travel in this direction all the way to infinity, which is where our graph would continue to move towards. Okay. So there is no right boundary for this graph. There's only a left boundary, and that's why we have 6 to infinity for our domain. Okay. Does anybody have any questions about that? Okay. The range is very similar. But now instead of thinking about the x-axis and the boundaries to the left and the right, for the range, we want to think about the boundaries of the graph on the bottom and the top. Okay. And we're going to be using the y-axis to sort of measure where those boundaries are. So again, we want to focus on this graph, this curved line over here. And now we want to say, okay, what is the lowest point that this graph goes down to? Well, I could draw a line here, and maybe I could say that that's the lowest point that the graph goes down to. Maybe I could draw a line here and say that's the highest point that the graph goes up to. But in reality, the graph is continuing to move in the upwards direction and in the downwards direction. So if I'm using the y-axis to measure what is the lowest y value that this graph goes down to, then my range should begin from bottom to top all the way to negative infinity, since the graph is going down to negative infinity. And the graph is going up all the way to positive infinity. So that would be my domain and range. Does anybody have any questions about that?
So that is also going to be in the test.
Mm-hmm. Yep, there will be two problems like this on the test where you'll have to give the domain and range of a relation or of a graph. Okay. All right, now we want to look at number 26. 27, 28, 29. Okay. So to give the domain and range of this function, I'm not sure what method Miss Cottier taught you guys how to do this, but I'm thinking that she probably had you set up a inequality that you have to solve. So whenever you're trying to find the domain of a function and it's a square root function, then what you need to do is take the stuff on the inside of the square root. That is, we need to take the 5x minus 3 and set up an inequality so that we can keep that stuff positive. So we're going to set this greater than or equal to 0 because we don't want to have any negative numbers inside the square root. If we have a negative number in the square root, then we would get an imaginary y value, and we don't want that. We want to keep, we want to have real numbers, not imaginary numbers. So we'll take the inside, the 5x minus 3, or whatever is inside the square root, set it greater than or equal to 0, and then solve this inequality. So we could add the 3 over to the other side. We would get 5x is greater than or equal to 3. And then if you divide both sides by 5, you get x is equal to 3/5. I'm sorry, not equal to, is greater than or equal to. So that tells us that our domain or our x values have to be greater than or equal to 3/5. And that means that it can be any number that's greater than or equal to 3/5. So we have no upper boundary there. So we can go all the way to infinity for our domain. And the range of our square root functions tend to be very similar to our domain. For a square root function like this, the range will always start at 0 and then always go to infinity. But if you want to know how you could get this 0 to infinity situation, you could simply plug this x value into your square root function, and then that would give you the 0. Does that sound familiar based on what you guys went over yesterday?
Yes.
Okay. Okay, so in the interest of time, we'll just go ahead and move on to the next problem. So for the next one, we're looking at a function that is called a rational function. And for a rational function, we sort of have to think about them like rational equations. There's some number for our x value that is restricted or that is not allowed for x. And so with these, we just need to inspect the denominator to figure out what the domain is. I know that the restricted value is that x cannot be equal to positive 3. Is anybody confused as to why that's restricted? And it's perfectly okay to be confused. Right? So the reason why it's restricted is because if we plug 3 into the denominator, we would have -7 over 0, right? 3 minus 3 would be 0. So since that is restricted, you could think about our x-axis as the domain of our function. And since we cannot have 3 in our domain, that means that the domain consists of everything to the left of 3 all the way to -infinity, and everything to the right of 3 all the way to +infinity. So if you were to write this domain in interval notation, then we would have everything from -infinity to 3 and everything from 3 to infinity. And since these are disjoint or disconnected sets or intervals, we have to join them with a union. Okay. And since the domain sort of looks like weird, the range will similarly look weird, where you will have a range from -infinity, but it'll go to 0 and from 0 to +infinity. So I usually find that that's a little bit more difficult to explain, especially at this point in the semester. But essentially, if you look at this whole expression, this -7 over x minus 3, that regardless of what number you put in for x, um, if you put a positive number in there, that was, let's say we put a positive number that's greater than 3, you would get a positive number in the denominator and a negative number in the numerator. So you would end up getting a negative value. It doesn't matter what value you put in for x, you're never going to get a 0. And usually I graph this expression with my students to show them that they will never get a 0. But in the interest of time, I would say if you need a further explanation on why the range looks like this, definitely talk with one of the tutors in Math World. But I guess my hint to you guys is that if you can figure out the domain, then the range is going to look very similar. The only difference is that this is going to be 0 here and this is going to be 0 there instead of whatever these numbers are. Okay, so let me go ahead and drag us through these last few problems. These should be not too bad, I don't think. Number 28. Number 28 says find f of -4 when this function is given. The function is equal to 4x squared minus 3x plus 5. Does anybody know how you would find f of -4? What is this telling us to do?
Plug in -4 to everywhere that there's an x.
Yeah, exactly. So this is saying evaluate the function when x is equal to -4, which means we're going to take -4 and plug it into the expression everywhere we see an x. So in order to solve this problem, we would write 4 times -4 squared minus 3 times -4 plus 5. And all we need to do is solve this or simplify that expression, and that will be it. Okay, so you could do this by hand, or you could throw it in the calculator. I'm going to do a little bit by hand. This should be 4 times 16, and then this is -3 times -4, so that would be plus 12 plus 5. Looks like I'm doing all of it by hand. This is 64 plus 12 plus 5, which is going to be 76, 81. And yeah. Is that what you guys got? Did anybody else get 81? Let me go ahead and throw this in the calculator so I can see. Times -4 plus 5. Okay. 81. Yeah. Cool, cool, cool. Okay, and now we need to do number 29. So number 29 is asking us to do something similar. It's asking us to evaluate f of -4 or find f of -4, but now we're using the graph. Okay. So does anybody know how you would find f of -4? And remember, this tells us that x is equal to -4.
Is that the thing where you just draw like a straight line up to where it hits the line?
You're exactly right. So we're going to go to this x value on the x-axis, -4. And if we were to put a straight line through -4, we would see that we are hitting the graph right here, and we need to evaluate it or give the y value. The y value here that corresponds to our x value is +4. So we can just say that f evaluated at -4 is equal to +4. And that would be your answer. Does that make sense, or is that confusing? Just as an alternative example, right? If we were asked to find f of, let's say f of 5, then I would do a similar process, right? I would go to the x value of 5, which is right here. I'm going to draw a straight line up. And where does my pink line intersect the graph?
2.
2.
Yeah, it intersects right here, which has a y value of 2. So my answer here would be 2. And if I wanted to do that same dance with f of 0, I would draw a straight line right here at 0. And it looks like it intersects here at 0. So in this case, f of 0 would just be 0. Okay. Okay. And the last problem that we need to cover is number 30. So we need to determine the intervals of the domain for which the function is increasing, decreasing, or constant. Okay. So what I like to do for this type of problem is I ask my students usually to go ahead and think about reading the graph from left to right as though you're riding a roller coaster. Okay. So if we start at the very far left of this graph over here, even though the arrow is pointing down, we want to ride the roller coaster from left to right. So even though this arrow is pointing down, we're really going to be going up, 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 as though we're riding a roller coaster. Again, we're reading from left to right until we get to this point right here. At which point, the roller coaster flattens out until we get to this point, and then it changes directions. Then the roller coaster starts going down. Okay. So essentially what we're saying is that this graph or this function has 3 different behaviors that we've been able to sort of label on the graph. There's a part of the graph that the graph is going up, labeled by these green arrows that I've drawn, where it's flat or constant, which I've labeled by just orange straight lines, and then where it's down or decreasing, represented by the red arrows pointing down. Okay. So when this question is asking you, what are the intervals of the domain for which the function is increasing or decreasing or constant? Well, when we're increasing, let me go ahead and just type this out. Increasing. We're just focusing on the green part of the graph. And we're just focusing on the domain, which is the x-axis. So the graph starts increasing here at negative infinity if we read it from left to right. So the x-axis really goes all the way to negative infinity, and it's sort of increasing in this direction from negative infinity all the way to this point over here. So I can say that this graph is increasing from negative infinity all the way to -2, and then it changes behavior. Right? Because once we get to this point here, which is at the x value of -2, then the graph flattens out. Then that would be the constant part of the graph. So the constant part of the graph is only represented by the flat part, which is between which two x values?
-2, 2.
Yeah, -2 all the way to 2. And then finally, the decreasing portion of the graph is bounded by which x value. So we start decreasing here at 2,
2.
and it continues decreasing in this direction, which would be all the way to positive infinity. So from 2 to positive infinity, the graph is going down. So that's how you would go about writing the open, usually it's the open intervals of the domain for which the function is increasing, decreasing, or constant. Okay. So I highly recommend just using that mental exercise where you're thinking about writing the graph like it's a roller coaster. Is the graph going up? Is it flattening and constant, or is it going down? Right. Does anybody have any questions about that one?
Now, when we're using these points, we're always going to be using parentheses, right? We're not going to be using
Right.
brackets, anything like that.
So usually for these problems, you're just going to be using parentheses. You're not worried about brackets. But I think usually in the tests that you will see, it will specifically say determine the open intervals of the domain. And when we say open, we mean all parentheses.
Okay.
Okay. Well, I know that was a lot. That was a lot for me as well. So I hope that you guys were able to hold on and capture some of that. Obviously, if some of it went over your heads, it was just a lot of material to cover. So if you need the additional support, make sure that you talked with one of the tutors in Math World. I'm going to be hopping into Math World here in a second at from 2 to 4:30 today. So if you do need some additional one-on-one time, I will be available. And I believe that Miss Cottier has created for you guys a practice test in Canvas. So let me go ahead and share this. Right, this is your Canvas page. Here, just briefly, I think she went over this with you guys yesterday. You can find the instructions for taking test 1, but she's also created some information here for practice for test 1. So just make sure that you review this. It looks like she's created a practice test for test 1 that have very similar questions to what are going to be on the test. It's not timed, and the grade is omitted from your course grade. So it's just an opportunity to see, what it is you're going to be dealing with when you go into the test. So you can find that in the module for the instructions for test 1 here. And again, if you forget what the instructions for test 1 are, she's going to go over them with you tomorrow, but they're right here. Remember, test 1 will open at 2 o'clock tomorrow. And on test 1, read through these instructions, you're going to have an hour and 45 minutes to get through 20 questions. So make sure that you've practiced well enough that you can basically bring down the number of little mistakes that you will make, right? Because the little mistakes are going to kill you every time. So you just need to make sure you get that practice in, because uh, it really is just a matter of getting practice and getting those reps in. So that is all I have for you guys today. If you have any questions, you're more than welcome to hang back and talk with me a little bit afterwards. But otherwise, I'll see you guys some other time, and good luck on your tests.